My name is Greg Kleinheinz. I'm the director for the Environmental Research and Innovation Center here at UW-Oshkosh. We call ourselves the ERIC Lab, short for Environmental Research and Innovation Center. The ERIC Lab is responsible for doing water testing at 5 regional laboratories around the Great Lakes. This is our main laboratory here at UW-Oshkosh. We employ a lot of students doing both field collection of drinking water and surface water samples. And we have clients from all over North America that send us samples for a variety of different types of analysis, including going out on the boats in Lake Michigan and the Lake Winnebago system. We've been involved in water testing for close to 30 years. So this is my 28th year here doing this. So collectively, with the whole team, we probably have close to 100 years of experience in doing a variety of water testing. Again, both groundwater, surface water, industrial sources, recreational, etc. In graduate school, I remember using Whirl-Pak bags, having them available in the lab and using them for a variety of things. And for whatever reason, we just haven't used those for a couple decades. And we do a lot of samples, so we do, I think, close to 20,000 different types of samples here. So storage is a big issue for us. We also have a core mission in sustainability on our campus and within our facility. And as part of reevaluating sort of greener ways that we can operate our laboratory, we're looking at other ways to use what we use now as our single-use sample containers, and a lot of the students have made comments about the sort of copious amounts of recyclables or trash, really, because it's not really recycled because of the type of plastic. So we were just looking at alternatives, and we were sort of fortuitously approached by somebody at Whirl-Pak about another issue, and it sort of spawned some ideas about how we may be able to sort of re-engage and use that product. We have a lot of field samplers, so they'll literally drive around with boxes of bottles in their trunk. And so it's a lot of storage space for us, not only in the laboratory, but then also having to carry, large amounts of bottles, and they're all different sizes. So if you collect something for sample A, you might need a liter size. If you collect something for sample B, it might just be 100 milliliters. So there's a variety of different types of bottles. So you can imagine how inconvenient it is to be constantly driving around with 3 or 4 different boxes in your vehicle. So the space in not only the lab, but also in the individual sampler vehicle was important. The bottles are also the ones that we use right now are pretty fragile. So they're a type of plastic that's prone to cracking when they hit the lab bench too hard, or somebody drops it inadvertently or something else. So we've had a number of samples that's happened to over the years, and it's not a ton, but when somebody then has to go back and drive 20 miles or 30 miles and resample a facility because somebody in the lab made an error, if the bag was a little bit more forgiving, that allows us to not have to inconvenience our partners. The only thing that we wondered is how would they work actually in practice? As I mentioned, we have lab applications and we have field applications, and both are very different. So were they gonna function in a way that allowed the staff and the students? And so we're at a university, so we are operating as a commercial lab, but we also are an educational institution. So we have students that are learning along the way, and so when they do that, they maybe learn sometimes hard lessons. And so if we can use the bag to help be a little bit more forgiving, that was always a goal. I think I talked to close to 20 of our staff and students, and not a single person had heard of a Whirl-Pak bag. And that was actually surprising to me because, as I mentioned, 3 decades ago, I remember seeing these in laboratories and things, and it was surprising to me that the sort of younger generation of scientists really had no familiarity with them. And so I'm not sure why that was. So they were a little skeptical because they didn't know what they didn't know. And so they're like, what is this bag thing, and why do they call it a Whirl-Pak? And so there was a lot of that at first, and it was education. Because we are a Safe Drinking Water Act certified laboratory, we have to do things. We do some Safe Drinking Water Act certified analyses, and so there's very precise standard operating procedures for those. We do non-certified analysis as well. We do sample collection. So a bag has to not only, in one application for for example, if somebody goes out to a recreational water site and collects a sample in a bag, they then have to put it in a cooler, which then has to be on ice. So are they rugged enough to withstand the ice and the transport in the cooler and the sort of jostling around? Can they be handled with one hand in the field and all these other sorts of things? And so those are very different requirements than in the laboratory. Now, will the bag stand up on the lab bench? Will it go in the incubator in a way that's organized like a bottle would? So there's all those sorts of questions. So we did both field testing. So we went out and used the bag, and we used a bottle that we use currently today. And we would collect recreational water samples side by side. We would bring them back to the laboratory. So they got the opportunity to do the field, both the physical collection and utilization of the product side by side, and then the actual analysis side by side. So that was one. And then in the laboratory, we also did them in the lab. So as we would do any other sort of analysis, we would put a sample in a standard collection vessel, and then one in a Whirl-Pak right next to it, and we would incubate those together. I think we did over 100 field samples and I think over 100 laboratory samples as well. One of the things that's leading us to adopt bag usage is the space issue. That's a big one, and the sustainability issue. So, and I'll just be honest, we're a University of Wisconsin company, right? And Whirl-Pak's a Wisconsin company, right? And so we like to support, companies in the state. So the space issue, and for us in the laboratory, the bags seem to function pretty well. And so we had no issues. In the field, they held up fine in the coolers. Even getting jostled in sharp ice and this, that, and we didn't have any sort of bag problems. Yeah, we're looking forward to finding different analyses here that we can utilize the bag and get rid of some of the bottles. We tried a couple of our users, so we said, hey, can we send you these bags and you'll send us samples back in the bags? And so we've started those trials. And those are not water samples; those are sort of industrial waste samples. So things like manure and sort of organic samples. And we think there's a lot of possibility for that because we end up sending large coolers out with a lot of air, sort of big empty bottles. And so if they can send back the Whirl-Pak bags, and so they get the bag and they look at it and say, this isn't going to hold enough. And then they start filling it up and they're like, oh, wait, this does get big. We're not there to demonstrate the whirling process, but anyway, they get the point. So so in terms of bag adoption, in the laboratory we've already started to find ways to do it, and in the field we're looking at ways to also collect samples of certain types in the bags where possible. It's allowed us to ship smaller containers. So again, when we look at like an overall footprint, we don't have to ship large boxes of things and then have them shipped back to us in large boxes. We can ship a small box to a client or to one of our field sites, for example. We can have one box that would have 100 bags, for example, in it. And then they get returned periodically over a period of time. And so instead of sending, a whole bunch of large shipments and spending a lot of, sort of carbon and cost and doing that, we're able to sort of at least eliminate about half of our shipping costs. We don't have overflowing disposal bins. That's one thing. So literally we would have, a lot of the analysis we do, we actually use multiple containers. So we'll do a collection in one, and then we have to put it in a different one in the laboratory. And so for one analysis, we might have 2 or 3 individual bottles that are single use and disposed of. So literally garbage can sizes of these bottles that, as a university that's trying to practice sustainability, it's not a real good picture when you just see all this plastic. And we know that the plastic that is getting used is not one that's recycled in our area anyway. I want to say we've probably cut down right now on about 30% of the bottles. We think in the end we'll probably get closer to 50 or 60% of them. Right now there are a couple things that we can't use the bags for, but for a lot of them we're still kind of discovering that. So for example, we're doing phosphorus collection, and so there's nothing special about the bottles we use for the sediment or for the water samples. And so, we had a box that was probably 2 feet wide by 18 inches by 18 inches full of bottles. And that's what we used last year. This year, sitting next to it was basically a large envelope full of bags that would do the same amount. So for us, that was a way to kind of cut down on confusion as well for the samplers. And so it's been pretty well received, even though it's new. So it's, again, to me, as a person in the business of educating young scientists, it's about letting them know that what technology, tools, and equipment is available to them to get done whatever it is they have to do, whether it's with us or sort of beyond the walls of our campus. And so even letting them know that this exists, I think is important, because there's a lot of applications that maybe we don't do today, but they'll use later, where they'll want to use that bag. The learning curve's been, I don't want to say it's been steep, but they've never seen these, and they don't believe that they stay sealed. They don't believe that they won't break. And so we've literally thrown them across the conference room. We've dropped them on the floor in the lab. And so it's a lot of, skepticism, because you don't know, right? And so until you see it in action, and every time the bags haven't leaked and they haven't broke, and people are like, wow, yeah, this is not anything that I ever saw in my classes. The only challenge we've had really is collecting those samples where you've got to hold the bag inverted and put it underwater. There may be ways to do that. I think in the lab, one of the learning curves, even on one of our staff, just trying to put them in the incubators. And I said, hey, we have this nice little rack here. Look at that. They're like, where's that from? I said, this is a Whirl-Pak bag rack. And they said, oh, wow, we have these for bottles, but we didn't know Whirl-Pak made these. And so, but they do, right? And so obviously other people have had that challenge. And so again, it's educating our staff and making sure that they're using all the tools in the Whirl-Pak sort of toolbox, if you will, right? So we have racks that we put bottles in, because we know it makes it easier to put them in the incubator. And so there are racks to put bags in. So that was one of the sort of simple obstacles that we just had to overcome. Instead of trying to stack them all up and have them sort of freestanding, it's just making them know that making them known that there's a rack that will help them do the same thing. We never had any leakage problems with the mechanism. As I said, that was one point of skepticism of some of the users that were unfamiliar with it. How can this, and we pointed out to them that, have you been kayaking or canoeing? And they said, yeah. And I said, do you ever use a dry bag? Well, yeah. And they're like, it's really no different. And so they're like, oh, and then the light bulb sort of goes on. But they're, again, they're programmed just because of their experience is to screw the top on a container. And then when you show them the whirling of the closing, then they say, oh, that's why it's called a Whirl-Pak. Otherwise, nobody really knows why it's called that. The bottles and bags can be treated the same way in most cases. I think it's when you're putting them on the counter, they're freestanding, using the racking system or some way to help keep them organized. It's like anything else in the lab. When you do something new and different, you kind of work through the workflow and the process, and we have to do things. We have a lot of diversity in the staff and the students that work with us, and so we have to make sure that our procedures and our protocols are, I don't want to call them bulletproof, but they're subject to revision, but they're also not very forgiving for those that might want to stray from how we want to do things. So we have to make it as easy, as straightforward for people. And so every person that comes in and is doing an analysis is doing it exactly the same way. So anytime we have one of those, like this pour pod or with the racking, anytime that somebody would come to us and say, oh yeah, I can't get them to stand up, or I can't this or that, we'll all put our heads together and come up with a creative solution that helps us address whatever that is. And that's not unique to Whirl-Pak bags. I mean, that's in the laboratory. Anytime you're doing anything new or different, you have to come up with the best way that it works for your laboratory. In most cases, it doesn't matter. We can use any sort of sample containers. There are some that have autofluorescence and different sorts of sterility checks that we have to do. And so those are some of the things that we're still looking at, because every regulatory agency that we work with has different requirements. So some of them say you have to do these tests on particular bags or bottles. Some say you have to do this. Some it doesn't really matter what you use. So each of those, we haven't run into any roadblocks that sort of stop us from using them. We actually did a number of drinking water samples, and so the regulatory requirement for that is 1 colony forming unit or MPN or less. You can't have anything, and they all came out pretty close. There was 1 sample out of I think 20 that came back with 1 coliform, which isn't unusual. That happens in any sort of sample container, and it probably has nothing to do with the container, and it probably has to do with sample collection by the person. So so we don't have any concerns with sterility, integrity of samples, et cetera. In the analysis that we're able to use those, like I said, we're cutting down on the amount of disposal by maybe up to even 75%. Sometimes we'd have whole garbage cans full of nothing but empty plastic bottles, and then we ended up throwing them out, and we know they go to a recycle bin, but we know they don't get recycled. So in terms of solid waste disposal, that's a lot less, and so I think that's a good story that our students leave with. So we haven't received any formal feedback on the use of the bags related to sustainability, but we are going through a green laboratory initiative on our campus, and so we're one of the labs that was chosen on this campus to go under sort of this evaluation for some sort of green lab certification. And so one of the things we want to highlight is the ability to use containers that are single use, but then they're still, a much more sustainable option than single use plastic. Back years ago, we'd use a lot of glassware, right? So glass pipettes, glass bottles, people would wash them, sanitize them. Modern laboratories just don't do that. We all use plastic. It's plastic this, plastic that, plastic this. So this gives us an alternative. And the first one that we've seen in quite some time that actually has a decrease in the amount of single-use plastic. My advice to other labs when they're considering things is keep your options open, keep your mind open to new and different things. As I mentioned, Whirl-Pak bags, I don't know the history of the company, but I know they've been around for at least 30 years. And so, if you haven't heard about Whirl-Pak bags, you haven't used Whirl-Pak bags, take a look. Because you don't know what applications you may have for them. And just because you haven't used them doesn't mean they don't have a place in some part of your laboratory operations. And I think just from our experience, we didn't use any Whirl-Pak bags. I think we actually had an old box stuffed under a counter for a while, but then, working with you, over the last couple of years, it's kind of opened our eyes to a product that, comes from down the road, almost literally, gives us another tool in our toolbox to be, still a quality laboratory, do all the things we need to do from a regulatory perspective and give quality information to our clients. But then also, sort of answer to our stakeholders with respect to sustainability and operating as efficiently as possible. If I had to summarize my experience with the Whirl-Pak bags, it's been refreshing, and it's been a look back at something, maybe a tool that in our laboratory that we can now use that was lost for some unknown reason for some period of time. So we're really happy that it's kind of come back to the forefront of our consciousness, and we can find ways to use that. If anybody has questions about adoption, about what kind of analyses, what kind of workflow, what kind of sample collection might somebody use with this, they can certainly reach out to me, and I'm happy to share our experiences with them. And if that helps somebody else not recreate some of the issues we've had and find them a better way to do their job, we're all about that.